February 15, 2013. A seemingly ordinary winter morning in Chelyabinsk, Russia. The sun had risen, and people were going about their daily routines. Little did they know, a silent visitor from space was about to turn their world upside down. At 9:20 a.m. local time, a blinding flash illuminated the sky. A massive fireball, brighter than the sun, streaked across the horizon. This was no ordinary meteor. It was a 20-meter or 66-foot asteroid weighing as much as 10,000 tons, entering the Earth's atmosphere at a staggering 40,000 miles per hour. The asteroid, heated by immense friction with the air, exploded in a blinding flash about 18 miles above the ground. This airburst released energy equivalent to 440,000 tons of TNT, 30 times the power of the atomic bomb detonated over Hiroshima. The shockwave from the explosion spread outward, reaching Chelyabinsk within minutes. Windows shattered in thousands of buildings, sending shards of glass flying like invisible shrapnel. Walls crumbled, roofs caved in, and car alarms blared in unison. The shockwave knocked people off their feet, leaving many injured and disoriented. As if the Chelyabinsk event wasn't unnerving enough, it coincided with an unsettling cosmic near-miss. On the very same day, another asteroid, designated as 2012 DA-14 or Duende, was making its own headlines. Duende, a 30-meter or 100-foot asteroid, zipped past Earth at a distance of just 17,200 miles. To put that into perspective, it was closer than the geosynchronous satellites that orbit our planet. This close encounter, while unrelated to the Chelyabinsk event, was a stark reminder of the constant cosmic dance between Earth and celestial objects. It highlighted the reality that asteroids, large and small, share our cosmic neighborhood, and that collisions, while rare, are not mere science fiction. The fact that two significant asteroid events occurred on the same day sent shockwaves through the scientific community and beyond. It underscored the importance of understanding these celestial wanderers and developing effective detection and mitigation strategies. The Chelyabinsk meteor served as a wake-up call, exposing the challenges we face in detecting and tracking potentially hazardous asteroids. While we have made significant progress in mapping the cosmos, finding these cosmic needles in the haystack remains a daunting task. One of the primary challenges lies in the vastness of space itself. Asteroids, even relatively large ones, are incredibly faint and difficult to spot against the backdrop of countless stars and galaxies. Their dark, often irregular surfaces reflect very little sunlight, making them even harder to detect. Furthermore, many asteroids have unpredictable orbits, making it difficult to anticipate their movements and assess potential threats. Their paths can be influenced by the gravitational pull of planets, collisions with other asteroids, and even the subtle push of sunlight. Adding to the complexity, many asteroids are relatively small, like the Chelyabinsk meteor, making them even harder to detect until they are very close to Earth. These smaller objects may not pose a global threat, but they can still cause significant regional damage, as the Chelyabinsk event demonstrated. Leftovers of creation. What are asteroids and where do they come from? Asteroids, often described as minor planets or space rocks, are remnants from the early solar system, cosmic leftovers from the formation of planets billions of years ago. These celestial bodies, ranging in size from meters to hundreds of kilometers, offer a glimpse into the building blocks of our cosmic neighborhood. Most asteroids reside in the asteroid belt, a vast donut-shaped region located between the orbits of Mars and Jupiter. This cosmic junkyard is thought to contain millions of asteroids, ranging in size from tiny pebbles to dwarf planets like Ceres. These asteroids are believed to be fragments of planetesimals, objects that never quite accreted enough material to become full-fledged planets. The gravitational influence of Jupiter, the largest planet in our solar system, likely prevented these planetesimals from coalescing into a planet. While most asteroids reside in the asteroid belt, some have been nudged by gravitational interactions into orbits that bring them closer to Earth. These near-Earth asteroids, or NEAs, are of particular interest to us, as they pose a potential impact risk to our planet. Close encounters near-Earth objects and the danger they pose. Near-Earth objects, or NEOs, are asteroids and comets whose orbits bring them within 1.3 astronomical units of the Sun, relatively close to Earth's orbit. These objects are of particular interest to astronomers and planetary defense experts because of their potential to collide with Earth. NEOs are classified into different groups based on their orbits and potential for close encounters with Earth. Atens, Apollos, and Amors are the most common types of NEOs, each with distinct orbital characteristics that bring them into Earth's vicinity. The risk posed by a NEO depends on its size, composition, speed, and trajectory. Larger asteroids, while less common, pose a greater threat due to their potential for widespread devastation. Smaller asteroids, while more numerous, may burn up in the atmosphere or cause localized damage. The impact of even a relatively small asteroid can have significant consequences. The Chelyabinsk event demonstrated that even an object a few tens of meters across can cause widespread damage and injure thousands of people. Scars of the cosmos, past impacts and their impact. Earth bears the scars of past asteroid impacts, a testament to the dynamic and often violent history of our planet. Craters, some visible on the surface and others buried beneath layers of sediment, serve as reminders of the destructive power of these cosmic collisions. One of the most well-known impact events occurred 66 million years ago when a massive asteroid, estimated to be about 10 kilometers in diameter, slammed into the Yucatan Peninsula in Mexico. This catastrophic event, known as the Chicxulub impact, is widely believed to have triggered the extinction of the dinosaurs and many other species. The impact released an unimaginable amount of energy, equivalent to billions of atomic bombs, triggering massive earthquakes, tsunamis, and wildfires. The impact also ejected vast amounts of dust and debris into the atmosphere, blocking out the sun and causing a global cooling effect that lasted for years. While impacts of this magnitude are extremely rare, they highlight the potential consequences of asteroid collisions. Smaller impacts, while less catastrophic, can still cause significant regional damage and disruption. Eyes on the skies, protecting our planet from asteroid threats. The Chelyabinsk event reminded us of the importance of planetary defense, the effort to detect, track, and potentially deflect asteroids that pose a threat to Earth. Significant progress has been made in developing technologies and strategies to protect our planet from these cosmic hazards. Ground-based and space-based telescopes scan the skies, searching for NEOs and characterizing their orbits. These observatories use advanced imaging techniques and software to identify and track these objects. Once a potentially hazardous asteroid is identified, astronomers monitor its orbit and refine its trajectory. If an impact is likely, several deflection strategies have been proposed. Kinetic impactor. A spacecraft would collide with the asteroid, altering its course. Gravity tractor. A spacecraft would fly alongside the asteroid using its gravity to tug it onto a different trajectory. Nuclear option. A nuclear explosion near the asteroid could push it off course. The choice of deflection method depends on the asteroid's size, composition, speed, and trajectory. International collaboration is essential in any effort to deflect an asteroid. Protecting Earth from asteroid impacts is a global imperative. By investing in research, technology, and international cooperation, we can develop effective strategies to mitigate these risks. With foresight and preparedness, we can ensure the future of life on Earth is not left to chance.